Today's lesson is going to start out with a fun little riddle. So just kind of remember, sometimes this might appear on a pop quiz. It may not, but just so you know. So, what do you call two L's? A parallels. Ha 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 ha. But right? Parallels, a pair of L's. Ha ha. Alright, just, something fun to start with. Because similar triangles are actually going to be using parallel lines. And we will be talking about that in reference to the triangle proportionality theorem. Alright, so let's go ahead and get right on into it. Okay? Triangle proportionality theorem says that if a line parallel to one side of a triangle intersects the other two sides, then it cuts that triangle proportionally. So if this line EF is parallel to the side BC, and it goes through these sides of the triangle, that means that the sides are going to have to be proportional. Okay? So that would mean that AE divided by EB would be equal to AF divided by FC. Okay? So let's put that into practice. It says here we need to find CY. What is this missing link? Remember that according to the triangle proportionality theorem, that this number divided by this number should be equal to this number divided by this number. Okay? So we have AX over BX equals AY over CY. So plugging that all in, let's move this up a little higher. So AX is really 9, BX is really 4, AY is really 10, and we still don't know CY. So what we have to do here with these proportions is we actually need to cross multiply. So 4 times 10 is 40, and 9 times CY is 9 CYs. Okay, so all you're doing here is you're cross multiplying. So to solve for CY, I divide both sides by 9, which means that the length of CY must be 4.4 units, whatever is in the problem. I didn't give you units in this problem, but if you had them, you had to make sure that you put them down. Okay? So since those are parallel, I can use the triangle proportionality theorem. Alright, let's do another example. PQ is parallel to one of the sides, LM. So the triangle proportionality theorem says that this piece here divided by this piece here must be equal to this piece divided by this piece. So we have 5 over 2 is equal to our unknown Pn over LP, which is 3. So by cross multiplying, 5 times 3 is 15. 2 times Pn is 2Pn. So then I'm going to divide both sides by 2. 15 over 2, you could leave it as the fraction, or you could say x equals 7.5. Okay, so Pn, well, I shouldn't write x. I should actually write Pn here. Pn is 7.5. Alright, now with theorems, sometimes we have the converse. Now, and this is true. Okay, the converse of the triangle proportionality theorem says if I already know that this side divided by this side is equal to this side divided by this side, then the two lines must be parallel. So let's put that into practice. Here I have some numbers, and I want to know, is MN parallel to KL? So let's do the triangle proportionality. 42 over 21. Is that equal to 30 over 15? If it is equal, then they're parallel. If it's not equal, then they're not parallel. So 42 times 15 is 630. 21 times 30 is 630. Remember, I'm cross multiplying here. Since these two numbers are the same, that means the sides are proportional. So I would write, because the sides are proportional, then MN is parallel to KL. Alright? Alright, now in this problem, we have a little bit of a problem. Notice that I don't know what AD and BE are. However, I do know that AC is 36 centimeters. And I also know that BC is 27 centimeters. So all I need to do to find BE is subtract. What is 27 minus 15? That will be BE. So BE here is 12. Now 36 minus 20 gives me the 16 I need here. So all we have to do now is put it into our proportion. 20 over 16 equals 15 over 12. We are going to cross multiply, right? Multiply. 20 times 12 is 240. 16 times 15, 240. So because they check out, that means the sides are proportional and that DE must be parallel to AB. Since the sides are proportional, then DE is parallel to AB by the converse of the triangle proportionality theorem. Alright, so the triangle angle bisector theorem. Remember, angle bisector cuts an angle in half. So an angle bisector of a triangle will divide the opposite side into segments whose lengths are proportional. Notice I did not say congruent. Proportional to the lengths of the other two sides. So that means that BD divided by DC will be equal to AB divided by AC. Okay? So let's go ahead and try an example. Here I have an angle bisector and I need to find RV and VT. So the first thing I need to do is that the side opposite of the angle is proportional to the other sides of the triangle. What that means is that x plus 2 over 2x plus 1 must be equal to 10 over 14. Okay, keep in mind that x plus 2 and 10 are in the same, what looks to be triangle, so I put them both on the top. So now we need to cross multiply, and I get 14 times x plus 2 equals 10 times 2x plus 1. Now what's important here is that we got to remember to distribute both items in with the distributive property. So I get 14x plus 28 equals 20x plus 10. Okay, so if you distributed incorrectly, you would notice by this step right here. So now what I want to do is I want to subtract 14x from both sides. 28 equals 6x plus 10. Alright, so now we need to subtract 10. 18 equals 6x, so x equals 3. But that was not what the problem was asking for. The problem was asking for is what is RV and what is VT? Well, RV is x plus 2, so that would be 3 plus 2, which is 5. And VT is 2x plus 1, where x is 3, so I get 6 plus 1 is 7. So that was the length of our sides. Alright, so what I'd like for you to do is go ahead and try these two problems here, and then we will come back. If you are looking for an example for these, basically I would flip back to, let's see, before we talked about the converse of the triangle proportionality theorem, we talked about finding a missing segment, so that's where I would look back. Alright, so what we have here is we're missing side BH. So I did x over 9 equals 9 over 15, cross multiply, and then divide by 15 to get 5.4. Over here we have the full side length 49, so I subtracted 49 minus 14 to get 35. So it's x over 8 equals 35 over 14, cross multiply, I get 14x equals 280. So x must be equal to 40. Or excuse me, 20. I don't know where I said 40 from. But it is 20. Alright, let's go ahead and try this problem. It's problem number 5. It's the angle proportionality theorem in the triangle. Pause here. Alright, so this is how you should have set up your proportionality. And then we need to cross multiply. So 7x times 108 is 756x. And then we do 144 times 5x plus 2. I need to distribute all of that inside there. So that would be 720x plus 288. Let's go ahead and subtract the 720x out from both sides. So I'm left with 36x equals 288. Divide by 36, x equals 8. But notice that's not the answer. I'm looking for SR and RQ. So SR is 7 times x, so 7 times 8 is 56. And RQ will be 5 times x plus 2. If x is 8, that would be 40 plus 2, 42. Alright, so there's your 2 answers for that. Alright, that's it for today. We will be watching, our next video will be over Pythagorean theorem and slope, something that we've already talked about, but just a quick review, because we're going to need that information a little bit when we get into dilations as it pertains to the coordinate plane. And then the next 2 videos will be the last ones for Unit 1, so we will be moving into Unit 2 very shortly. I will see you guys later.